In the past, we were given a function and we were asked to find its derivative, or we needed to find its derivative for whatever purpose. Maybe to graph the function, maybe to find the max min, maybe, who knows, different reasons. This time, we are given the derivative and we are asked to find the function. So given the derivative, find the function. There are two different notations, but you would say, and I would have to agree with you, really, is that such a big deal? Here are the two possible notations. Yes, in a way, they are the same, but in a way they're different, and we have to understand this difference in notations. Given f prime, find f. Given a function that we know is a derivative, but we are calling that function f, we will find uppercase f. So the derivative is also a function. So I can be given f prime, which signifies the derivative of the function, or I can be given a function denoted by f, in which we are told, hey, listen, this is a derivative of a function, but I'm not going to call it f prime. I'm going to call it f, just because. In that case, when we find the antiderivative, we have to denote it by uppercase f. Okay? So the formula that we have to look at, you remember, when we differentiate, so what is the antiderivative? This is the antiderivative. This is the antiderivative of this. What is the antiderivative of f? Is this. So finding the function given the derivative. I have the derivative, find the function. This is the antiderivative of that. This is the antiderivative of this. So when we differentiate x to the nth power, we know that this is n times x to the n. Minus 1, of course. Okay, so now how do I find x to the n? What function prime is x to the n? So if I have here x to the fourth, then I will have 4x to the third. But if I have x to the fourth, what do I differentiate to get x to the fourth? First of all, it has to be power 5, right? Because I have to subtract 1 from it. And then when I bring power 5 in front, I have to simplify it with something in the denominator. 1/5. Yes, indeed. So this must be x n plus first over n plus first. So when I differentiate x to n plus 1, I bring n plus 1 in front, which will eventually be canceled with the denominator, and I end up having x again. So let's look at a couple of examples before we move on. Given f prime, I let you choose. We have your book. If you don't want to choose, I'll choose. Oops, wrong book. Okay, this is 4.9. It's on page, problems are on page 349. Please choose, if you'd like, anything from 24 through 48, but something that gives f prime for now. 24 through 48, 25 through 48 on page 348, 348, and 349. Just an example with f prime. Okay, 1, 2, 3, I'll choose. 32. We are given f prime, and that is 5x to the fourth minus 3x squared plus 4. We're also given some information. I will copy it for now. Before we talk about it, just copy it. So disregard it for a moment. We're going to come back to it in a few minutes. Okay. So we're given a derivative. We're given basically a function that is a derivative. We're asked to find the function whose derivative is this.
So that will be f of x. 5 is 5. For x to the 4th power, I have to increase the power by 1 and divide by that number according to this. Increase the power by 1 and divide by that number. And then minus 3, x to the 3rd divided by 3. Now I'm going to stop and ask you, what function prime is 4? Indeed, awesome. Indeed, 4x. And now plus, what prime is 0? Plus any constant. So this is a constant. I will simplify 5 with 5, 3 with 3, and so on and so forth. So the function is x to the 5th minus x to the 3rd plus 4x plus c. And this is basically not one function, but a family of functions, all depending on c. If c is 0 is a function, if c is 5 is another function, if c is 3 is another function. It's a family of functions called the most general antiderivative of f prime given in the function in the problem. Yes, Vanessa?
Can you know how you get f of x to answer the full answer?
I simplified the 5 with 5, and I got x to the 5th, 3 of 3, and I got x to the 3rd.
Or you just simplify this? Or are you doing get rid of it?
Yeah, because I have 5 at the top and 5 at the bottom. So I simplify the factors.
Question.
Yes?
When it comes like on the test or something, I mean, I know this is probably a very basic one.
It's
and
okay.
We're just learning it, but like if we had something like that on the test, do we have to show that middle part if we're able to?
No, that's fine. But what if you have fractions? Maybe,
Yeah, I mean,
yeah.
like, this is a simple
If it's,
one. but-
yes, of course, it's fine. It's absolutely fine. Good, so this is a family of functions. For any c, you get a different function. A family of function called the most general antiderivative of f prime. However, we are given a side condition. What does this mean and what is it used for? What do you think it's given to us? To find the constant. In other words, to find the unique function, the unique antiderivative of f prime. They don't want us to find a whole family of functions. They want us just one, a particular one. So f of negative 1, it says, is 2. So f of negative 1 will be negative 1 to the 5th minus negative 1 to the 3rd plus 4 times negative 1 plus a constant c equals 2. I don't like having two equal symbols in an equation, so I should not write the left-hand side. But this is where it's coming from, so I'm just going to put an arrow. So this is negative 1, and this is negative 1 with minus in front, which is positive 1. And then this is minus 4 plus c equals 2. These two go away, therefore c is 6. So we're asked to find one function. We are going to write that function right now. So f of x equals x to the 5th minus x to the 3rd plus 4x plus 6. This is the only function that fulfills the given conditions, such that f of negative 1 is 2. Any questions? Any questions on this? So please choose now anything else, or I will. Okay, I would like to look at '30. The third derivative of t is e to t plus e to negative 4. No, plus t, sorry. Plus t to negative 4. We haven't discussed e to t, so let's discuss that.
which function prime will be e to t? In other words, I'm asking, what is the antiderivative of e to t? Of course, this is the only one. Very good. In order to find, we're asked to find f of t. In order to find f of t, given the third derivative, what do I have to find first? Oh, yes, of course. So let's find the second derivative. Which function prime is e to t? Very good. Plus. Maybe I shouldn't rush but with the plus, but that's fine. Which function prime is t to negative 4? Well, it's t to negative 4 plus 1 over negative 4 plus 1 plus a constant c. I will rewrite as e to t minus 1/3 t to negative 3 plus a constant c. In this problem, we are not given any conditions, which means we are asked to find the most general antiderivative. Yes?
Is that negative 1/3 times t to the negative third, or?
Yes. There is no operation symbol. I cannot change the division. I can only change it into an addition or subtraction. I can only change the division into a product. There is no symbol between negative 1/3 and t to negative 3. So I brought, actually it's a very good question. A divided by b is the same with 1 over b multiplied by a. And that's what I wrote. A divided by b is the same with 1 over b, which is negative 1/3, multiplied by a. So we've done this, I think, several times in limits and when we differentiated, right? Good. So if there is no symbol or just a dot, it's definitely a product. Very good.
You always add the plus c, even if there's no constant.
But very good question. So the second derivative, if I differentiate this function, I get that. Would you agree? This prime is this. This prime, I bring the power in front, I simplify, and I subtract 1 from the power. And when I differentiate the constant, I get 0. When I differentiate the constant, I get 0. So I differentiate this and I get that. I differentiate this, that I get this. I differentiate the constant, I get 0.
What's the constant here?
When you differentiate any constant.
So do you just kind of like assume, because like what if we were just given the problem like e to t plus like the original equation was just like e to t plus or minus like t to the whatever power, but it didn't have a constant, do you just assume?
It could be 0.
So this is a derivative. I don't know what the second derivative is, what the first derivative, and I don't know what the function is. So maybe something got lost, disappeared on the way. It's an excellent question. I don't know. So maybe it had, so for example, it's a very good question. I'll come back. We didn't finish, but it's such a good question that I have to explain a few things. So for example, if we have x to the 5th, f of x to the 5th, okay? Plus x to the 3rd, and minus 2x. And let's say plus 1. The first derivative is 5x to the 4th plus 3x squared minus 2. The second derivative is 20x to the 3rd, right, plus 6x. The third derivative is 60x squared plus 6. If I'm given this, I have to build it back. So I'm giving you this now. How will you get this back? You have to assume that some terms disappeared.
So like
And you have to build them back. If you don't build them back, then and you just assume that there is nothing, then you are going to determine the second derivative as 60x to the 3rd over 3 plus 6x.
So as we
But that's not the
like, are we gonna see, so like what if the equation was just x to the 5th plus 3x, or x to the 3rd, and that was like it? when we have like the constants in there, are you gonna find out, like, I guess, when you,
If you are given conditions, yes.
so you would find out there's nothing. If
But
not,
you will
just find
always
something.
try to find the most general antiderivative.
Okay.
Especially if you're not given conditions, you have to take into account any possibility and every possibility. Yes.
If you're building it back up, like all the way back up to the function, how do you even have multiple constants that you have to take it back for?
Of course. The first one will be C1, the second one will be C2, the third one will be C3, and so on and so forth. That's exactly what we're going to do. Excellent question.
So you always put the plus C at the end.
Always.
Okay.
Yes. I have to assume that there is an unknown portion that I may discover or not. But yes, I have to assume that the unknown is there. Great question. Thank you, all of you. Great job. Okay, so this is only the second derivative. So now we continue with the first. So which function prime is e to t? Well, the answer is e to t. Then minus 1/3. Which function prime is this? So it's t to negative 2 over negative 2. Plus, which function prime is this? Exactly. Thank you, Chris. Plus, so now I have no choice. I have to go back and name this as C1 plus C2. Great job. Yes, Vanessa?
Can you go over how you got that again?
Which part?
Like, the whole thing, like how you got.
So this prime is this. Then I copy negative 1/3, and we discussed that formula. T to n is t to n plus 1 over n plus 1.
Okay.
And then which function prime is C1? It must be C1t. And then which function will be 0 is a constant. Is that okay?
Yeah, the more derivatives isn't when we find the second derivative, because we have the third derivative now. Once we find the second, there's one constant. We find the first, there's two constant. And then when we go one more, we'll need three.
Yes,
Okay.
absolutely. So now this will be e to t plus 1/6 t to negative 2 plus C1t plus C2. Final step, we are finding the function. Not the function, we are finding the most general antiderivative, the entire family of functions whose third derivative is the given, e to t plus t to negative 4. So it's e to t plus 1/6 t to negative 1 over negative 1 plus C1 times what?
T.
Squared over 2 plus, very good, plus, that's it. So let's clean it up a little bit if we can. E to t minus 1/6 t in the denominator. I'm bringing t to negative 1 in the denominator. Plus C1 over 2 t squared plus C2t plus C3. And this is final. This is the most general antiderivative of the given third derivative. I think we should also look at 45 before we look at situations with velocity, acceleration, etc. when we apply this. Yes, please.
I don't understand what you did with the first constant in the f of x. Like before you.
This one here?
Yeah.
So what?
I don't know how you got that from the equation of already.
I have t, I have to increase the power of t by 1 and divide by the same number. So that one is t to n plus 1 over n plus 1.
Okay.
The same formula, x to n plus 1 over n plus 1. So going backwards with the powers, I increase the power by 1 and I divide by the same number. Why? Because when I differentiate, I bring the power down, I simplify, and I get the t back when I differentiate. Is that better?
I don't know how you got the 1 over 6t.
This was from before, 1 over 3 times 1 over 2.
Well, yeah, I don't know. I'm talking about the circle answer.
The same thing with this. I increase the power by 1 and I divide it by the same number. T to n plus 1.
I know how you got.
Oh.
I'm talking about 1 over 6t.
Oh, because this is t to negative 1, it goes down to the denominator. This is negative 1. Positive 1/6 times negative 1 is negative 1/6.
Did you just cross multiply it, or?
I multiply 1/6 by -1. So I get -1/6, and then I brought t to -1 to the denominator. Better?
Yeah.
Everyone? Okay, very good. So let's also look at 45. Same page, 349. So we have the second derivative this time, which is 2 plus cosine x. And we're given f of 0 is -1. And we're given f of pi over 2 is 0. So obviously in this particular case, we're not asked to find the most general antiderivative, right? We are given conditions to help us do what? Find C or C's. Yes, excellent. Good, so now please dictate the first step. So f prime is?
Negative sine x.
Yes, because this, no, but remember we are going backwards. Which function prime is 2? 2x. Which function prime is cosine x? And sine plus a constant c. So let's verify. 2x prime is 2. Sine x prime is cosine x. C prime is 0. Any questions? Any questions? Do I have any information about f prime? I don't. So I have to continue. I will call this C1. Any questions? Stop me, please. Good. So f of x. Which function prime is 2x? 2x squared over 2 for everyone to see. You already simplified. That's perfect. Which function prime is positive sine x? Very good. Plus, which function prime is C1? C1x plus
C2.
Excellent. Now you simplify, and yes, you get x squared minus cosine x plus C1x plus C2. Now we have f of 0 is -1. What does this mean, and how do I write it? 0. Correct. Very good. 0. What is cosine 0? With minus in front. And this is 0 and plus C2. So it happens that C2 is?
0.
Excellent. Good. So then the function right now looks like this. X squared minus cosine x plus C1x. Now I'm given one more piece of information. It says f of pi over 2 is 0. We plug in pi over 2, and we get pi squared over 4 minus.
0.
Exactly. Very good. Awesome. And then plus C1 times pi over 2. Pi C1 over 2. So then pi C1 over 2 equals negative pi squared over 4. Any questions? Any questions? Yes, Vanessa?
So, when you got pi squared over 4, did you bring the 2 in front and you multiply that by the denominator?
No. I'm replacing. I'm evaluating. X is pi over 2. I have to plug in pi over 2 and square.
And that's why, okay.
And then cosine pi over 2 is 0. And then I have to plug in pi over 2, and it's C1. And then I move this to the other side to solve for C1. Is that okay, everyone? Yes? Okay. So I'll simplify by pi, both sides. Multiply both sides by 2. So then C1 equals negative pi over 2. I divide both sides by pi, and I multiply both sides by 2. So C1 equals negative pi over 2. And now we have the unique function. That's single function, one function that fulfills all characteristics. So
all the information given. X squared minus cosine x minus pi over 2x. This is it. This is the function whose derivative is given to us, was given to us, and fulfills also those two conditions given to us.
I have a question.
Yes, please.
So on the previous problem,
Yes.
there was C1 times t or C1t, and then we raised that had an exponent of 1, and then we did the n minus n plus 1 and all that, but we didn't do that for this one.
Because we had the second derivative, we didn't have the third derivative.
Okay.
We had the second derivative, we only had two steps. One step to get the first and one more step to get the function.
So if we had another step, we would have to do that with this one.
Yes, if we were given the third derivative, yes, I had three steps. But
Okay.
I'm given the second derivative, so I only determine the first and then directly the function.
Okay.
Very good question. Is that clear, everyone? Yes? Okay. So now let's look at 62 on page 349. We are given the acceleration 3 cosine t minus sine t, and I think there is a 2 in front if I'm not, yes, there is a 2 in front. And s of 0 is 0, and v of 0 is 4. So here's the question. A particle is moving with a given data. Find the position of the particle. Find the formula for the distance, in other words. So what derivative is a of t for the distance formula? The second derivative, awesome. So then what do I have to find first? The velocity. So let's find the velocity. Which function prime is 3 cosine t? I agree. Yes, we agree with 3 sine t? Very good. 3 sine t prime will be 3 cosine t. Very good. So now which function prime is negative 2 sine t? Plus 2 cosine t. Excellent. Plus 2 cosine t plus a constant c. Very good. We have a piece of information. We are given a piece of information for the velocity. We are told the velocity at 0 is 4. Why is this given? What am I going to do with it? Very good. Excellent. So how much is sine of 0? Yes, Brandon, you want to say something? Yes?
I was just confused on why we're finding v of t.
Very good. So if I have the distance and I differentiate, I get the velocity. If I differentiate the velocity, I get the acceleration. So then I'm given the second derivative. I have to come back to the velocity in order to determine the function.
Okay, so we're trying to find s of t.
The distance, yes.
Okay.
Yeah. Good. So sine of 0 is 0. Cosine 0 is times 2 is 2 plus c equals 4. How much is c? 2. So the velocity function is 3 sine t plus 2 cosine t and plus 2. Now we are ready to find s of t. So how do I find s of t? What function prime is 3 sine t? But negative, right? Negative 3 cosine t, because when I differentiate cosine t, I get negative sine t. With minus in front, I get the plus. What function prime is 2 cosine t? Plus, which function prime is 2? 2x or t, yes, perfect. Plus a constant c, and I'm going to call this one c1, not to be confused with the previous one. Or d or whatever letter, but not c. Good. And now we are given that s of 0 is 0. So, how much is cosine 0? Very good, negative 3. How much is sine 0? Perfect. How much is 2 times 0? Okay, so plus c1 equals 0. How much is c1? Very good, awesome. Great job. So then we determine the unique function. There is no other function that fulfills all given conditions. -3 cosine t plus 2 sine t plus 2t plus 3. And this is it. And this is the distance or the position function, the function that gives the position of the particle at any point in time. And there's only one. Ready? Chapter 5. Integrals. Now, here's a question. I learned from you and a lot, and I hope to continue learning. Would you agree that this section does not belong to what we did in chapter 4?
It doesn't make any sense to put it in.
Right? Would you agree? And I hope you're not getting confused on test 3. Please don't get confused. You're not going to have this on test 3, going backwards. You're only going to be given functions where you're going to have to differentiate. Okay? This section does not belong in chapter 4. And you will see this is all about that. So I don't know why they put it in chapter 4. I totally disagree with it. Okay, perfect. Integrals. Before I even explain what an integral is, so this is later. We have a lot of preparation to look at. So here it is. Let's suppose I have a function like a very simple one. Let's say x squared plus 1. And I'm going to choose a very user-friendly interval, let's say 0 to 2. And here's our question. We want to find the area under the graph of this function, f of x, between 0 to. We want to find the area under the graph of this function between 0 and 2, obviously between the graph and the x-axis. I want a graph to see what we're facing. So this is 0, 1, and 2. So I'm going to just diminish the, well, maybe I don't have to. I'm going to just do this. 0, 1, and 2. 1, 2, 3, 4, 5. So when x is 0, obviously y is 1. And when x is 2, y is 5. Would you agree with this graph? This is the graph of x squared plus 1 between 0 and 2. And the area in question is this area. So we are asked to determine the area under the graph of x squared plus 1 between 0 and 2. At this point in time, we do not know how to find the exact area. We will, hopefully by the end of the class today. But we can approximate it. So I'm going to continue the question and say, I cannot find it exactly at this point. So finding the area is really not possible at this point. So I'm going to say, approximate the area. The area using 4 subintervals. Using 4 subintervals of equal width, of course, of equal width. So the interval between 0 and 2 will be divided equally into 4 parts. This is the width of the interval, of the subinterval.
we will denote it by delta x. And it is 0.5. And of course, this one is 0.5. Same width, and this one is 0.5. And of course, this one is 0.5. So coming back to my graph, I will split the interval as exactly how we showed it a second ago into 4 equal subintervals, like here. And we're going to be looking at 3 situations. The area with 4 subintervals L, or in some books it's A, L4, maybe that's better. A right 4 and A mid 4. Let's stick with that. We don't have to denote in any way, shape, or form. We can just write what it is, but I think the notation is self-explanatory. What does this mean? What is L? What is R? And what is M? Left, right, mid. So this is using the leftmost point. This is the same, but with the rightmost point. And this is with the mid point. What's all this? Okay, so let's start with the area using the leftmost point and 4 subintervals. Ready? They are all approximations. These are all approximations. They are not exact. Okay, so I'm going to graph it again. Here's the graph. Four subintervals. And we want to find L4. So I'm dividing the area using 4 subintervals. And now I'm using the leftmost point. What does that mean? For the height of the subinterval or the rectangle. So here's the leftmost point for the first piece. So this will be the first area we're going to take into account. Here is the height on the second piece, and this will be the area of the rectangle we're going to use. Here is the third height, and this will be the area we are going to add. And here comes the last one. Here is the height, and this will be the area we're going to use. Remember, this is 0, this is 0.5, this is 1, this is 1.5, and this is 2. So the area using the leftmost point and 4 subintervals will be base times height plus base times height plus base times height plus base times height. Since the base is always the same, I'm going to put it in front 0.5 and open a bracket. The first one will be f of 0 plus the second one will be f of 0.5 plus f of 1 and plus f of 1.5. And this is the area approximated, the approximation of the area, of the exact area, using the leftmost point of the interval, of each subinterval. Question for you now. Will this be an overestimation or an underestimation of the correct exact area? Right, because there are some holes in here. Excellent. Okay, so let's determine it quickly. So AL4 will be 0.5 in front. F of 0 is 1 plus f of 0.5, 0.25 plus 1. F of 1 is 2. And then 2.25 plus 1. f of 1.5. 1.5 squared is 2, yes?
I don't understand where the, like, up there where the 1 and 1.5 are coming from.
So this interval uses the height of the leftmost point, which is f of 0. This interval uses the height right on top of 0.5, so this height would be f of 0.5. This interval uses the height right on top of 1, so this height will be f of 1. I divided the entire interval into 0, 0.5, 1, 1.5, 2, 4 equal subintervals. So this point is at 0.5, so the height will be f of 0.5. This point is at 1, so it will be the height at 1. And this will be a height of 1.5. I cannot use this because I'm done with 4 subintervals. Is that okay? So we're adding all these. What do we get? So 2, 3, 4, 5, 7.5. 0.5 times 7.5. Am I correct? Is it 3.75 the area? Yes?
Yeah.
Okay, perfect. And this is obviously an underestimation. Would you agree? So the area is 3.75. Moving on to the second possibility.
I have a question.
Sure.
I'm trying to figure out where you got 1 plus 0.25.
It's f of 0, I plugged them in the function.
Okay, so,
F of 0, f of 0.5, I went back to the original function x squared plus 1 and plugged them in.
okay.
So f of 0 will be 1, f of 0.5 will be 0.5 squared plus 1, and f of 1 will be 1 squared plus 1, and f of 1.5 will be 1.5 squared plus 1. Is that okay?
Yeah.
Perfect. So now let's look at the second possibility. Here it is. A, R4. Ready? So now we are using the rightmost point. Now this is the height of the first subinterval, or the first rectangle, or the first area. Now this is the height of the second one. And that's the area of the second one. Here's the height of the third one. And finally, the height of the fourth one. Can anyone dictate? Of course, it's still 0.5. But can anyone dictate now the area of the first? 0.5 times what?
I don't know much of that.
Very good. Plus. Very good. Plus. Very good. Plus. Excellent. Remember, still 4 subintervals. You only can have 4 heights. Very good. So now this is 0.5. F of 0.5 I just determined here is 1.25, sorry. F of 1 we determined it is 5. F of 1 is 2, I'm sorry. Plus f of 1.5, I already determined it here, 3.25. And f of 2, that is 5. So it's 0.5 multiplied by, what do we have here? 3, 4. So it's 450. 1150, is it? Correct me if I'm wrong, please. Is it? So I got 5.75 this time. Is this an underestimate or an overestimate of the correct exact area? Of course, because we have pieces that are not considered, right? They're not under the graph. Overestimate. Okay, now last time. Here's the graph. But now careful. We have 0, we have 0.5, we have 1, we have 1.5, and we have 2. But now we're talking about a M4. So each subinterval gets a height right in the middle. So right here in the middle, I will have the height. Here in the middle, height. Here in the middle, height. Here in the middle, height. So careful now, look at the picture. This is the height, and this is the area. I'm sorry, I went too far. So here's the height, right at the middle. So you're going to see it better on the second one. You're going to see it even better on the third. You're going to see it even better on the fourth. So this is the height, this is the height, and this is the height. Yes?
I don't understand why the graph is like changing, why that area is.
It's not changing. I have the exact same graph, but this time the height is not going to be the left, it's not going to be the right of the subinterval, it's going to be right in the middle. Nothing changes. One second, Vanessa. So here I had this height. Here I had this height for the subinterval. And here I have this height for the same subinterval. Nothing changes. So I can determine the area of this rectangle using this height, or using the height in the middle. Right now I'm using the height in the middle. So I'm not changing the area. The area of the rectangle will be different because this is one number and this is another number and this is a totally different number. But I can determine the same area using this height, or this height.
So we have to find all of them and then add them up.
Yes. Like we did before.
Okay.
Exactly. Yes, I'm sorry. Yep. Better? Okay, very good. So now we have still 0.5. The width of the interval is still 0.5, but this time it's f of 0.25 because that's where the height is. And now the height for the next one is 0.75. F of 0.75 plus. Now the next one will be f of 1.25. And the last one will be f of 1.75. I'm only changing from the first scenario to the second scenario to the third scenario. I'm only changing the height. The rectangle stays the same. I can approximate this rectangle using this height, leftmost point, rightmost point, or midpoint. And they all have to stop on the function. So this stopped on the function, this one stopped on the function, and this one stopped on the function as well. Yes?
So will that always apply for the midpoint?
In the middle of the interval, depending on how many intervals I have. Absolutely.
Okay, so
If I have four subintervals and I have from 0 to 2, I divide it into four equal subintervals, and then the middle one must be at 0.5. And the middle one must be at 0.75. And the middle point must be at 1.25, and this one must be at 1.75 for this scenario. Good. If you have the number, please give it to me. If not, I will calculate it.
I got 9.25.
Impossible.
Oh, wait.
Let me tell you why impossible. And here's how we know. The overestimation
Or
was-
yeah, 6.2.
right, and the underestimation,
I
right?
didn't divide, yeah.
Okay, so you have to multiply by 0.5 probably. Okay, so I should have asked that before starting this. Okay, so from these three possibilities for this function, we use the leftmost point, we use the rightmost point, and we use the midpoint. Which of these three do you think is the best approximation of the correct area?
Midpoint.
Right, because it has the least amount of error in any direction. even overestimation or underestimation, right? So that, yes, Ashley?
So we got 37.5 for the underestimation, right?
No.
3.7.
3.7.
Yes.
Okay. I was very confused. I was like, how is the overestimate 5.75?
So this is 5.75 and this is 3.75. And now we're trying to determine this. And I want to show you a way of determining this. So in edit, go to stat and edit a list. And the list is 0.25, the x values. The next one is 0.75. The next one is 1.25. And the next one is 1.75. Yes, Ricky? Say it again. We're going to stat, press stat, and edit. And we edit the first list, 0.25, 0.75, 1.25, and 1.75. And go to L2 now and highlight L2. Go up there and highlight L2. And write L1, second and 1, squared plus 1. If we want all the areas, we can also put parentheses. Let's try from the beginning. Let's clear this. Left parenthesis, L1 squared plus 1, close the parenthesis, and multiply it by 0.5. And press enter. What do we think you need to do? Do you need something else? Okay, so yes, so plus 1, close the parenthesis, and multiply by 0.5. So these are all the areas of each subinterval. And here's what I'm going to do next. I don't want to do this by hand. So I go to stats, and I go to calculations, and just do one variable stats, but it has to be on L2, not on L1. So second and 2. And press enter. No, I have to go to calculate. Calculate and enter. Okay. So this is the sum. This is the area. If we did not get 4.625, then something is wrong. So 4.625. Yes?
When you typed in L1 squared plus 1, why did you divide it by 5? Or did you?
The width of the interval is multiplied. 0.5 times the height, which is x squared plus 1, plus 0.5 times the height, plus 0.5 times the height, plus 0.5 times the height, base times height.
Okay. So you divided it or you multiplied it by 0.5? Is it
Multiply.
0.5?
Yeah, the width of the subinterval is 0.5. The entire interval is 2 units.
Okay.
Yes, the first one is the mean. The second one is the sum. We're going to talk about it in 5 minutes. So I'm going to talk about this. And this is the square, the sum of the squares, the variance. And this is the standard deviation, and this is the population standard deviation. This is the number of entries or the number of elements in the list. Minimum, the first quartile, the medium, the third quartile, and the maximum. Okay? That's for stats. I only used one thing here. I didn't need anything else. I just wanted the calculator to give me the sum of the L2, which is the entire area.
Why did we use 0.25, 0.75, 1.25, and 1.75?
Between 0 and 0.5, the middle is at 0.25. So for this, here I used f of 0. Here I used f of 0.5. In the middle, I have to use f of 0.25. The middle between 0 and 0.5 is 0.25.
And then wouldn't it be 0.5 for 0 and 1?
No, 0.5 is the left point. The next one between 0.5 and 1 is 0.75.
Oh, I understand.
So on the real line, this is 0.5, and this is 1. Where is the middle?
Okay.
Better? Other questions here?
Where did you put it at that?
Stat, the same stat and calculations. So stat, and go to calculations. And I used one variable stats, the very top one, enter. But make sure that you change this into list L2 with second and 2. Because the data we want the sum for is in list L2. Ashley?
How do you get, so that's what mine just
To
comes up.
stat. Let's take a look.
Give me like a list or.
Let's take a look. But that's fine. So then in parentheses, you put list L2 and you get 4.625.
Thank you.
Yeah, it's, there are different calculators, different software, and now the more sophisticated ones come up with something else.
So just make sure that you put in parentheses the list that you want to determine the area, the sum for. Is that clear, Ashley? Just
Yeah.
make sure that you put the list, because if you put L1, you're gonna get something else. Good, very good. Perfect questions. Anything else? Okay, so now the moment of truth. Here's my next question.